The structure of an atom is a foundational topic that applies to a lot of different things that we'll do in chemistry. So there aren't any supporting topics that I could think of for this video, but you'll find that in later videos that this is often referenced as one you need to watch before you go on to something. So let's talk about atoms. And I love this cartoon, which I found from a website that makes t-shirts, where they say, never trust an atom, they make up everything. And what's great about this picture is you can see this atom has an inside here, which is its nucleus, and it's got this guy floating around over here and this guy floating around over here. Those are the electrons. So we can look at a more formal picture of this, keeping in mind that our electrons are moving so fast that to presume that we know exactly where they're at is a little bit sort of not really possible. We can say the electrons are probably in this region, but we don't know exactly where they're at. What we do know, though, in general here, is that our electrons are floating around or rotating around the nucleus. This middle here, part here, is my nucleus, and then my electrons are floating around outside of the nucleus. The nucleus contains, you can see in our picture, both protons and neutrons. Oh, looks like we should have talked about subatomic particles. So just in case you missed that or you're not familiar with it, electrons are negatively charged particles. You can see that there. Neutrons have zero charge, hence the zero, and then protons all have a positive charge. And protons and neutrons get packed together really tightly into the nucleus, and the electrons are floating around. Floating's really not the right word. They are moving around the nucleus on the outside. Oh, never mind. I was apparently going to talk about neutrons and protons here. So here's just a summary of what we just said. Let's hit it again. In the nucleus, we find the protons, which have a +1 charge. They're relatively massive. Now, by relatively massive, we're not talking like big, like tanker truck big. We're talking big compared to the electron, which is really, really tiny. The number of protons are going to identify the element. So if you know that the number of protons of a particular element, then you know what that element is. None of the other subatomic particles, the neutrons and the electrons, they don't necessarily identify an element, but a proton, the number of protons, always will. The neutrons are also located in the nucleus. They have no charge. Like the protons, they're also relatively massive. And that will have implications for how we decide what's called the mass number of the atom. We'll just use the protons and the neutrons to do that. The electrons, on the other hand, like I said before, they are on the outside of the nucleus. They have a -1 charge, and they're relatively light. And students sometimes are a little bit perturbed by the idea that we'll add up the mass of the atom, but we won't include the electrons. It's because they're really only about 1/2000th of the mass of a proton or a neutron. So they're very, very light. When you look at the periodic table, there's some information that's given to you in each of those element boxes. The atomic number, the number of protons, is generally written at the top of the box. The atomic mass, this is actually the average mass of the atoms in an element, gets written at the bottom. This is not the mass number. That's actually something else. Mass number does not actually show up on the periodic table. So don't get those two confused. The element symbol is written in the middle there, and then sometimes the element name is included, and sometimes not. In a neutral atom, we would know that, for instance, on carbon, we would know that this has 6 protons. In a neutral atom, we would also know that it must have an equal number of electrons. So we would say this also has 6 electrons. Atoms are neutral, so if we said we have an atom of carbon, you would automatically know, oh, it has the same number of electrons as protons. If the number of electrons changed on an atom, then we would call it an ion. Oops, I wrote in my stuff. So just to summarize here, My atomic number is equal to my number of protons. My mass number, which I've been referencing, but now we can actually talk about, is going to be equal to the number of protons in the nucleus plus the number of neutrons. It's not the same as the atomic mass, so don't get those two confused. This will always be, the mass number will always be a whole number, right? So it couldn't be 12.01 because we're adding up a number of protons and a number of neutrons. So it's like saying 5 plus 4 will somehow equal 9.2. That just can't happen. 5 plus 4 will always equal 9. Your charge on your atom, if it's not neutral, so this would come from, we have an ion present, is going to be the number of protons, and we're going to subtract the number of electrons. And that works out well because if you have more electrons than protons, you'll have a negative charge. And if you have more protons than electrons, then you'll have a positive